They say the worst-case scenario for Comet 3 I/Atlas is a Hollywood-style disaster, an asteroid hitting Earth, a rogue planet careening through the solar system. But what if the real threat is nothing we can see or measure? What if the worst thing isn't a collision, but revelation? This visitor, hurtling toward us at impossible speeds, isn't a threat to our planet. It's a challenge to our perception of reality. It's an ancient time capsule carrying secrets from a galaxy we barely know, and its very existence might force us to confront uncomfortable truths about what's really out there. We're not talking about a threat to our physical survival. We're talking about a threat to our assumptions, our comfort, and our place in the cosmic pecking order. The question isn't whether 3I/Atlas will hit us. It's whether we're ready for what it might reveal. Buckle up, because tonight, we're diving headfirst into the abyss where science meets the wild unknown, where everyday explanations fall apart and the thrill of what if grips your soul. The real question isn't if this visitor will vanish into the void. It's if we'll spot the moment it chooses to stick around. And by the end of this journey, you'll be hooked, wondering, are we truly alone, or is the cosmos playing a game we're only just starting to understand? If this sparks your inner explorer, grab your telescope and join amateur astronomy groups tonight. Your backyard stargazing could contribute to the next big discovery. Let's kick things off with the heart-pounding basics. Could this cosmic intruder spell danger for humanity? Flashback to that fateful day on July 1st, 2025, when astronomers at Chile's powerful Atlas telescope locked onto a faint glimmer in the night sky. This wasn't your average shooting star. It was screaming in from beyond our stellar neighborhood, its path screaming outsider. Dubbed 3I/Atlas, or formerly C/2025 N1. It's our third verified guest from another star system, hot on the heels of Oumuamu's enigmatic 2017 cameo and Borisov's glowing 2019 flyby. But hold on, what if this one's packing secrets that make the others look like child's play? What if it's forcing us to rethink everything from cosmic accidents to calculated invasions? Think about it. With two predecessors already teaching us that the galaxy flings out wanderers like confetti, this third arrival amps up the mystery, hinting at a universe teeming with these nomadic messengers. Each one carries whispers from distant stellar cradles. But what if 3I/Atlas is whispering something far more intentional? Unlike the cozy, looping orbits of our local asteroids and comets, this bad boy carves a wild, hyperbolic curve through space, with an eccentricity over 1.0 that screams independence from our sun's gravitational leash. That means it's not tied down. It's a free agent, blasting in from the direction of the Lynx constellation at speeds that'll make your head spin. By late October, it'll skim closest to the sun at a mind-blowing 130 miles per second, about 58 to 61 kilometers per second in excess velocity, zipping across the U.S. in less time than it takes to brew coffee. Sounds epic, right? But here's the hook that keeps you glued. Beneath all that predictable math, what if the scariest outcome isn't a crash course with Earth, but a mirror held up to our own ignorance? What's at its closest? NASA calls it straight. Just a quirky comet, no doomsday device in sight, with its perihelion on October 29 to 30th at about $1.40, placing it comfortably between Earth and Mars orbits. But let's crank up the intrigue. What if we peel back the layers? The Hubble Space Telescope has been eyeing it since day one, capturing that telltale glow as frozen gases boil off in the sun's heat, forming a hazy coma that extends hundreds of thousands of kilometers. Then the James Webb Space Telescope jumped in on August 6, sniffing out a weird overload of carbon dioxide in its makeup, an unprecedented 8:1 CO2 to water ratio, plus traces of carbon monoxide, OCS, water ice, and dust that screams born under alien skies. Doesn't that tickle your curiosity? What if this chemical freak show isn't just odd geology, but a signpost to something smarter, something watching? And with SphereX adding its infrared insights, revealing an extended CO2 coma stretching at least 348,000 kilometers, the plot thickens, activity kicking in way beyond where typical comets wake up past Mars orbit. Telescopes around the globe are teaming up like never before, from radio dishes like those in the SETI network listening for any artificial whispers to optical giants mapping its every move. So far, all natural vibes, with only the expected emission from sublimating ices and no anomalous signals. This is astronomy's dream team in action. proving it's from the stars are harmless as a distant firework, with ground-based observatories confirming its interstellar origins through precise astrometry and spectroscopy. Yet, here's where the adrenaline kicks in. What if harmless is the perfect cover? What if pushing past the facts uncovers threats not to our planet, but to our comfy worldview? Space is lousy with these drifters, cosmic rejects kicked out during distant planet bursts through gravitational slingshots or stellar explosions, doomed to roam for eons. Each one whispers tales of far-off worlds, and none packs a punch. Oumuamua was cigar-shaped and tumbled oddly. Borisov spewed unusual gases, but both stayed safe. As outlets like The Guardian and Science Daily have noted, it's a cosmic curiosity, not a catastrophe. A nudge that the universe is wilder, more interconnected, and stranger than our daily grind lets on, offering a glimpse into galactic deep time from stellar neighborhoods billions of light years away. But imagine if the true enigma isn't the stories it tells, but the doors it cracks open to wilder tales, ones where visitors aren't random, but rigged with intent, perhaps even carrying encoded messages in their volatile mixes. Stay tuned, because this ride's just revving up, and if you're as captivated as we are, dive deeper by following live updates from NASA and ESA websites, or join online forums to discuss the latest spectra. Your questions could inspire the next observational campaign. Now, let's amp up the wow factor with the raw power behind this beast. Its velocity, scale, and ancient roots that scream epic saga. Clocking in at over 130 miles per second, it's outpacing bullets by a factor of 150, holding steady even as the sun tugs at it with hyperbolic excess velocity of about 61 kilometers per second, unchanged by billions of years of wandering. That's not just fast. It's a testament to a brutal past, maybe slung out by exploding stars, multiple gravitational encounters with rogue planets or black holes, or even the chaotic mergers of early galactic arms. But pause for the thrill. What if this ramp up in speed from past visitors? Oumuamua at 26 kilometers per second, Borisov at 32 kilometers per second. Isn't chance, but clue to something orchestrated. A pattern begging us to look closer. Perhaps a sequence of scouts increasing in sophistication? Sizing it up is tricky thanks to that glowing veil obscuring the nucleus, but current forces from close stellar passes could rip it apart. High-speed collisions with micrometeoroids or interstellar dust could erode it to nothing, and relentless cosmic ray bombardment could alter its structure entirely. Survival like that sparks questions about resilience that could flip from natural grit, perhaps a thick, radiation-hardened crust, to engineered armor designed to withstand the void. And age? Oh! This thing's a relic, with analysis from its motion relative to the galaxy's rotation suggesting origins in the Milky Way's thick disk, an older stellar population from when our galaxy was young, chaotic, and forming in a frenzy of mergers billions of years ago, potentially predating our entire solar system by up to 5 to 10 billion years. It's like a time capsule, etched with the galaxy's wild youth, carrying records of chemical evolution from an era when the universe was less than half its current age of 13.8 billion years. Its path? All wrong for the usual galactic spin, approaching from an unusual angle that tags it as a stellar elder, with orbits messy from eons of gravitational tugs and galactic evolution. But twist it. What if that odd entry isn't random but navigated, hinting at smart steering the show, using gravitational assist like an interstellar pinball wizard? No worries on impact. Its zip guarantees a clean getaway, with closest planetary approaches measured in astronomical units, not kilometers, and no chance of solar capture without massive energy input. Observation's a tease, though. It peaks at magnitude 11, bright enough for big scopes under dark skies, but vanishes in solar glare at its most dramatic moment around perihelion, when activity should peak with jets and outbursts. Coincidence? Or a plot point in a bigger story where what we can't see, perhaps subtle maneuvers or activations, matters most? Adding to the challenge, its southern sky approach favors observatories in Chile and Australia, but global networks are adapting with coordinated campaigns. This paints a gripping portrait. A survivor of epics, blasting through with physics that awe and assure, embodying cosmic endurance in a fleeting visit. The universe dwarfs us, operating on scales where billions of years are mere chapters, yet we predict its path flawlessly years in advance using centuries of celestial mechanics from Kepler to modern simulations. But what if beyond the math lies a twist that redefines danger? Not crashes, but awakenings to intelligences that play the long game. If this fires your imagination, support space exploration funds through petitions or donations to organizations like the Planetary Society. Your contribution could help launch missions to intercept future visitors. Shifting gears to molecular magic. That CO2 overload is a game changer, turning this into a chemical detective thriller. Webb's infrared gaze on August 6 revealed a coma dominated by carbon dioxide, with that jaw-dropping 8-to-1 ratio to water that's off the charts for any known comet, making it one of the most extreme volatile signatures ever recorded. Typical comets follow a predictable script. Water ice sublimates first at modest temperatures, creating vapor-heavy comas mixed with dust, followed by carbon monoxide, then CO2 and traces like hydrogen cyanide or methanol. The ratios tell stories of formation temperatures, distances from their parent stars, and post-formation processing. But 3I/Atlas has rewritten the rules entirely, belching CO2 like an industrial powerhouse, even at distances over $3 Australian, well beyond Mars, where most comets remain dormant lumps of ice. And get this, it was active early, producing a detectable coma extending hundreds of thousands of kilometers, defying expectations and begging the question, what hidden heat source or mechanism defies the cold vacuum? Theories swirl at the coma itself. Perhaps it formed near its natal star CO2 snow line, where carbon dioxide froze out preferentially from the protoplanetary disk, creating a nucleus rich in that gas. Alternatively, its extreme age, potentially billions of years older than our sun, could mean cosmic ray processing has modified the surface, creating a radiation-baked crust that seals in water while allowing more volatile CO2 to escape through cracks or pores. A third idea involves insulating dust mantles built up over geological timescales, acting like cosmic bubble wrap that prevents deeper water from heating while letting CO2 percolate out. Plausible? Absolutely, and supported by models of interstellar chemistry. But here's the edge of your seat hook. What if it's not natural at all, but crafted a chemical code for something bigger, like an energy source or marker left by advanced builders? Webb's near-infrared spectrograph detects these molecular fingerprints with extraordinary precision as sunlight heats the coma and molecules emit at specific wavelengths, revealing not just composition, but potential patterns. Imagine if those emissions encode information, subtle modulations that look random but aren't, or indicate deliberate engineering to mimic a comet while serving a surveillance role. It's not nurseries. Yet, when we venture beyond theoretical, no gravitational disruption flinging planets into chaos. Cold, precise celestial mechanics deliver a verdict that lets us breathe easy. With orbital lingering suspicion, space agencies navigate risk communication masterfully, acknowledging the emotional weight of interstellar, while emphasizing facts. Our primitive instincts flare at unknowns approaching, but vast scales and geometry make encounters benign wonders. Past visitors provide reassuring context. Oumuamua sparked debates with its shape and acceleration but proved harmless. Borisov displayed classic activity without peril. 3I/Atlas follows suit, scientifically fascinating yet dynamically inert. Our understanding forms a solid base. We know its speed, trajectory, CO2, rich composition, great age, and thick disk origins. World-class telescopes like Webb, Hubble, and ground arrays deliver detailed views of its behavior, with no artificial signals or maneuvers. Yet lurking beneath certainties are unknowns. Precise nucleus size, Hubble's refining perhaps under kilometer, surface versus bulk chemistry for CO2, exact natal system or encounter history. Crucially, none alter risk. Media coverage reflects maturity, highlighting value over hype, with visuals telling natural tales. Hubble's coma images Webb spectra, evolving emissions. Every measurement reinforces a natural comet with alien signatures, obeying universal laws. The physical worst case? Debunked. Mathematics clear. Observations consistent. Conclusions reassuring. This visitor comes in peace, by accident or design. But now, step beyond consensus into speculation, where worst cases challenge understanding, not bodies. Revelations of populated prominence, natural via snow lines, rays, mantles, no leaped artificial without exhausting explanations. Lessons from Oumuamua. elongated shape, acceleration explained by outgassing, no signals, natural. Approach, openness with rigor. Scientific method holds all to evidence. Artificial claims need positives, not gaps. Responsible media labels speculation, preserving public trust. But value? Sharpens distinctions, develops tests falsifying natural hypotheses, reminds of surprises. Future data. Perihelion spectra for unexplainable chems, astrometry for anomalies, monitoring for patterns. Burden on exotic ideas, natural consistent with physics, prior visitors. Even natural, it's extraordinary. Alien environments, ancient processes, galactic history. Profound discoveries from ordinary, like quasars, waves. If intrigued, volunteer for SETI home or similar. Process data, spot signals. Escalating the drama, dark forest doomsday. Pure fiction fuel. Cosmos' jungle. Civilizations hiding prelude Sishin's novel and SETI discourse. Silence a survival amid predators. If 3I/Atlas a probe? Staggering. Billion-year survivor mimicking comets, with spectra outgassing, properties faked. Engineering. Volatiles for disguise, sensors, comms, power via radioisotopes, fusion rays, fields. Push to conclusion. Anomalies. Structured signals, corrections, deployment of minis to Venus, Mars, belt, Lagrange points. Surveillance net. Humanity's crisis. Who speaks? UN, agencies, nation scientists. Consensus amid division. SETI shifts, broadcast risk. Response data for watchers, silence wisdom or fear. Communication aggression or curiosity. Debates reveal us. Crisis comms. Inform without panic, objectivity amid unknown, verified versus speculative. Expert panels, briefings, balanced transparency/stability. Misinfo explosion, conspiracies, cover-ups, rational discourse vital. Tech implications, propulsion energy, materials revolutionize, if allowed. Unsettling, temporal. Ancient civ extinct, ghosts executing missions, automated across time. Evidence? Zero, behaves natural. Exercise illustrates perspective shifts, surprises. Ponder, join SETI forums, discuss ethically, prepare minds. Deeper dread, great filter ghosts. Fermi's where, universe life-friendly yet silent. Barriers snuff sieves, abiogenesis rare, self-destruction common. If 3I/Atlas tech makers fate, billions old, galaxy different survived. Timescales, human civ 10,000 years, this eons. Engineering, materials durable as stars, energy eternal, software adaptive. Capabilities protect yet vanish. Resource depletion, wars, internal collapse. History warns tech outpaces wisdom. Our challenges echo. Alternative. Transcendence. Uploads, merges, higher dimensions, undetectable. Galaxy's age. Billion stars. Exploration expected. Silence demands explanation. SETI listens cautiously. Discovery transforms the strategy. Guardrails. Data natural. Speculation philosophical. Confront development. Sustainability. Filter warn/inspires. Balance exploration/wisdom. 3I/Atlas artifact. Inheritors learn. Avoid pitfalls. Stakes. Survival contribution. But real, natural. Observation resolves. Inspired. Advocate sustainable tech policies. Shape fate. Fermi's echo amplifies. Silence profound. Interstellar sample galaxy. Show tech. Engineer materials, isotopes, designs. Yet natural. Advanced silent emissaries. Invisible signatures. Proof. Narrowband radio, none natural noise. Unnatural thermals. Equilibrium, solar heated. Maneuvers grav plus outgassing. Natural aligns theory. Ejections common. Simulations predict nomads. Rubin Observatory. Dozens yearly statistical tests. Chem diversity. CO2 rich expands volatile range. Natural across stars. Biases. Detections favor directions, brightness. Sample small. Future. Rubin. Infrared scopes characterized precisely. If probes, deviations emerge. Philosophical. Silence suggests rarity, undetectability, choice. Evidence accumulates loneliness, but limited. Universe surprises. 3. I/Atlas piece and puzzle. Engage. Stargazing apps hunt, contribute. Cinematic climax. Silent seed swarm. Outermost speculation. Suspend principles for imagination. 3. I/Atlas delivery. Microseeds in ice, nanotech, or bioentities dormant, triggering on heat, radiation, atmospheres. Panspermia engineered. Life seeding or invasion. Near sun. Fragments eject, enter planets, replicate via local resources. Von Neumann machines building fleets. Spreading exponentially. Detection subtle. Anomalous microbes, tech glitches, ecosystem shifts. Ethics. Tamper, study quarantine. Implications. Upward biology overrun. Time lag. Senders extinct. Auto systems persisting. Seeding blindly. Or pangalactic life that evolves universally, blurring natural/artificial. Scenario escalates. Seeds activate on Earth, integrating DNA, sparking evolutions or malfunctions, plagues. Response. Global protocols, biodefenses. But evidence zilch. Pure plot for pondering contact forms. Thrill. Preps thinking on astrobiology ethics. CTA. Fund astrobiology research via NASA/ESA grants. Decode life's origins. Prepare for seeds. To extend the epic further, let's delve into potential future encounters. What if 3I/Atlas is a harbinger of a wave, with surveys like the Vera C. Rubin Observatory gearing up to spot several interstellar objects per year starting later to high-res imaging, perhaps spotting surface features like artificial craters or antennas. The excitement builds. If anomalies appear like unexplained heat spots or velocity tweaks, the world unites in a real-time detective story. Add layers with human elements. Astronomers losing sleep over data streams, amateurs contributing backyard photos, kids inspired to study STEM. CTAs abound. Download apps like Stellarium to track it yourself, or support crowdfunding for private telescopes. Speculate wildly. What if it's a library, encoded data in ice crystals, unlocked by lasers? Or a warning beacon from a doomed sieve? The possibilities endless, but grounded in real science pushing boundaries. Finally, circling back. 3I/Atlas, natural marvel or cosmic Trojan horse. You've journeyed from discovery drama to chemical enigmas, threat debunkings to mind-bending speculations, hooks pulling through every twist. Real takeaway. The universe amazes, delivering ancient secrets via fleeting guests. But don't stop. Follow missions on YouTube, donate to telescopes via the SETI Institute, share wonders with friends. Your action could unveil the next chapter, perhaps even proving we're not alone. Are we ready for what comes next? The stars await, calling you to look up and dream bigger. The stars await, calling you to look up and dream bigger. But what if this interstellar visitor, 3I/Atlas, is just the opening act in a cosmic drama we're only beginning to grasp? As it streaks towards October 29 perihelion, glowing with carbon dioxide-rich coma that defies our expectations, the questions pile up faster than the data. Is it a natural comet, a billion-year-old relic from a distant star's birth pangs, or something far stranger, a probe cloaked in ice, a silent envoy from a civilization that might no longer exist? The thrill of this mystery isn't just in what we see through our telescopes, but in what it forces us to imagine about our place in the universe. Let's dive deeper into speculative fire, weaving science and wonder into a tale that'll keep you staring at the night sky, hungry for answers. By the end, you'll be itching to join the hunt, whether through a backyard scope, a citizen science app, or a bold push for humanity's next leap into the stars. Picture the scene. Observatories worldwide are buzzing, their dishes and lenses locked on this fleeting guest. The Vera C. Rubin Observatory, set to revolutionize sky surveys later this decade, promises to spot dozens of interstellar objects yearly, turning rarities like 3I/Atlas into routine marvels. But here's the pulse-pounding hook. What if this is a warm-up, the first in a wave of visitors carrying secrets we're not ready to decode? Each could bring a new chemical puzzle. Imagine one with methane-heavy ices from a gas giant's nursery, or ammonia signatures hinting at formation in a frigid molecular cloud. The diversity alone is staggering, suggesting a galaxy where planet formation spins wildly different tales. But twist the lens. What if among this parade lurks the real deal? A probe so advanced it tweaks its disguise in real time, reading our observations and adjusting to stay hidden? The thought sends chills. A machine smart enough to mimic a comet's every move, from outgassing jets to brightness flickers, while quietly scanning our system. If that grabs you, download the Stellarium app tonight and track 3i/Atlas yourself. Your data could tip off astronomers to something extraordinary. Now, let's ramp up the stakes with a human angle. Picture astronomers hunched over screens in Chile's Atacama Desert, sifting data till dawn as 3i/Atlas's spectra pour in. They're not just crunching numbers. They're chasing a legacy, knowing this object could redefine their field. Meanwhile, amateur stargazers worldwide are joining the fray, power of collective curiosity. Join it. Share your photos on social media with hashtag 3iAtlasWatch and spark a viral hunt for clues. Let's push the speculative envelope further. What if 3i/Atlas is more than a probe? It's a library? Imagine its icy nucleus isn't just frozen gases, but a crystalline archive, data encoded in molecular structures, readable only by tech we haven't dreamed up yet. Picture a laser from a future observatory hitting it just right, unlocking a galactic encyclopedia. Star maps, histories of vanished civilizations, or blueprints for tech that could leapfrog humanity centuries forward. Or darker. What if it's a warning beacon, sent by a long-dead race to flag a cosmic hazard we're blind to, a rogue black hole, a predatory intelligence, or a galactic reset event we can't fathom? The possibility crackles with urgency. Could we redirect missions like Psyche or Juice, launching this September for a close flyby? A spacecraft skimming 3i/Atlas could snap high-res images, revealing artificial features, geometric scars, metallic glints, or antenna-like protrusions. Fund space exploration advocacy through groups like the Planetary Society. Your support could push for such a daring intercept. Now, let's zoom out to a cosmic perspective. The galaxy's 400 billion stars have been churning out planets for billions of years. If even heavy coma perfect mask, broadcasting data back to a mothership light years away via tech we can't detect, gravitational waves, quantum entanglement, or a subspace channel straight out of sci-fi. The hook. What if its mission isn't to contact us, but to entering our planet's skies as harmless dust, but starting a slow, relentless transformation? These could be von Neumann machines, self-replicating probes that build fleets from local resources, reshaping ecosystems or even our biology. Picture a future where Earth's skies shimmer with alien auroras, or new microbes spark evolutions we can't predict, uplifting life or rewriting it entirely. The ethical minefield is dizzying. Do we study, destroy, or quarantine these seeds? Detection would be subtle. Unexplained genetic shifts in marine life, odd atmospheric chemistry, or tech glitches from nanotech interference. The stakes. A new dawn for humanity or an unintended invasion. Fund astrobiology research through NASA or ESA grants. Your dollars can uncover life's cosmic origins before it's too late. But let's ground this in the now. Current data paints 3i/Atlas as a natural comet. Its trajectory follows gravity's script. Its CO2 emissions fit exotic but plausible formation models, and its silence in radio bands aligns with cometary norms. Yet, the unknowns keep the fire burning. Precise nucleus size remains elusive. Hubble's refining it to maybe 300 to 500 meters, small but mighty. The CO2 dominance might be surface only, with water ice buried deep, awaiting perihelion's heat to erupt in spectacular jets visible from Earth. Or it could be bulk, a clue to alien stellar conditions we're only starting to model. We can't pinpoint its birth star, but its thick disk origin suggests a chaotic youth, perhaps near supernova or in a dense cluster. These gaps don't spell danger, but fuel wonder. What else is out there, and how will Rubin's flood of data reshape our theories? Let's imagine a future where 3i/Atlas's legacy sparks a revolution. By 2030, Rubin's cataloging hundreds of interstellar objects, each a new puzzle. One might show a metallic sheen, another erratic maneuvers. Space agencies launch interceptors, CubeSats or repurposed probes like OSIRIS-RX, chasing these nomads for samples. A single dust grain could reveal alien isotopes or nanotech traces, rewriting science. Picture global teams decoding these live stream to billions, with kids coding algorithms to spot anomalies. You could be part of this. Learn Python with free online courses and analyze telescope data via citizen science platforms. Your code could flag the first artificial signal. Deviation from the norm isn't a fluke of nature, but a deliberate signature. The object was over 3 astronomical units from the Sun, well beyond Mars, when this was detected. Most comets show very little activity at such a distance. Yet, this one was producing a massive, detectable CO2-dominated coma that extended hundreds of thousands of kilometers from its nucleus. This inexplicable activity at an impossible distance raises an unsettling question. What if this chemical signature is a deliberate broadcast powered by a system we can't yet comprehend? Several theories attempt to explain this phenomenon naturally. Perhaps 3I/Atlas formed near its natal star's CO2 snow line, where carbon dioxide could have condensed. Or maybe its surface chemistry was altered by eons of cosmic ray processing, creating a protective crust that's sealed in water while allowing CO2 to escape. A third possibility is that insulating dust mantles developed over geological time, acting like cosmic insulation that prevents water access while allowing more volatile CO2 to percolate and escape. But what if all of these natural explanations are just a distraction from the most unsettling possibility? That this chemical signature is an engineered fingerprint, a deliberate signal from an ancient intelligence. This isn't an isolated incident. Comet C/2016 are 2 pan-stars also displayed an atypical volatile composition. Could these chemical outliers be part of a larger pattern? A signature that points toward a cosmos populated by intelligences we're only just beginning to detect through their chemical fingerprints? After all the analysis, all the numbers, and all the scientific scrutiny, the supposed worst-case scenario proves to be refreshingly mundane. No Hollywood catastrophe awaits. No civilization-ending impact threatens Earth. The precise celestial mechanics deliver a verdict that should allow us to sleep soundly. But what if the true worst-case scenario isn't about physics at all? What if it's about what this visitor might represent in the speculative shadows where our instruments cannot reach? The initially alarming speed of 3I/Atlas is actually a comforting fact. Objects on hyperbolic trajectories moving at such velocities cannot be captured by the sun's gravity. It's moving too fast to linger and cause trouble, performing its cosmic flyby before disappearing back into interstellar space. But what if this very speed, this inability to be captured, represents something more than natural orbital mechanics? What if it hints at deliberate design and precise timing? We're so focused on physical danger that we're blind to other kinds of risks. The worst-case scenario isn't what 3I/Atlas might do to us. It's what it might reveal about us. What if it's not a comet, but a probe? A silent sentinel sent by an ancient civilization, not to harm us, but to observe us? What if its unusual chemistry is an anomaly, but a purposeful signal? For now, the evidence points overwhelmingly toward 3I/Atlas being a natural comet. But the speculation isn't without purpose. It forces us to ask critical questions about what distinguishes natural from artificial phenomena in space. It challenges our assumptions and pushes us to imagine a universe far stranger and more populated than we dare to believe. We're now stepping deliberately across the threshold from established fact into the realm of speculation. Everything that follows should be understood as a thought experiment, not a scientific conclusion. The baseline remains unchanged. NASA and every mainstream astronomical institution describe 3I/Atlas as a natural cometary visitor. The object displays classic cometary behavior, follows predictable orbital mechanics, and shows spectroscopic signatures consistent with sublimating ices. Occam's razor, the fundamental principle of scientific reasoning, strongly favors the natural explanation, but science has a history of surprises. Pulsars, which were first detected as mysterious radio signals, were so regular they were briefly designated LGM little green men before being identified as rotating neutron stars. Fast radio bursts baffled astronomers for years before revealing themselves as signatures of exotic cosmic phenomena. Could 3I/Atlas represent another example of nature proving stranger than our initial assumptions? The speculation about an artificial origin isn't emerging from a vacuum. Harvard astrophysicist Avi Loeb, who gained attention for his unconventional interpretations of Oumuamua, has already floated similar possibilities for 3I/Atlas. His position, clearly labeled as opinion, suggests we should remain open to the possibility that some interstellar objects might represent technology rather than natural phenomena. What would constitute convincing evidence for an artificial origin? We would expect to see signatures that distinguish it from a natural object. Coherent radio emissions, for instance, might indicate onboard electronics or communication systems. These signals would need to be clearly artificial in origin, not the random electromagnetic noise that all objects emit, but structured transmissions that couldn't arise from natural processes. Non-gravitational accelerations inconsistent with outgassing would represent another telltale signature. While natural comets often show slight deviations from their pure gravitational trajectories, if 3I/Atlas were to change velocity in ways that couldn't be explained by gas production, it might suggest some form of propulsion. So far, none of these artificial signatures have been detected. Radio telescopes monitoring the object have found only the silence of space. Its trajectory follows the laws of celestial mechanics without unexplained deviations. The carbon dioxide dominance that makes 3I/Atlas chemically unusual doesn't, by itself, suggest an artificial origin current models dare to suggest. Imagine for a moment that this is not a random flyby. What if this is a targeted flyby? What if this object is a surveillance asset, a data-gathering probe sent by an ancient intelligence? Its unprecedented speed and unusual chemistry could be signatures not of alien formation, but of alien intention. A civilization so advanced that mimicking natural orbital mechanics is child's play. They could have designed a probe to look and act exactly like a natural comet, perfectly blending in with the cosmic background. Perhaps the high concentration of carbon dioxide isn't a byproduct of natural processes, but a deliberate broadcast method. What if the very molecules we're detecting are encoding information? The carbon and oxygen atoms could be arranged in a specific non-random pattern, a message embedded within the chemical composition itself. This would be a form of communication so subtle and sophisticated that it would be invisible to our current radio telescopes. It wouldn't be a radio signal, but a chemical signature, a cosmic Rosetta Stone waiting to be deciphered. And what about its extreme age? If 3I/Atlas is indeed billions of years old and originated in the galaxy's thick disk, what does that imply? It could mean that this is not a new mission, but one that has been ongoing for eons. It could be part of a vast intergalactic surveillance network, with these silent probes constantly crisscrossing the cosmos, gathering data and reporting back to their creators. The universe could be teeming with these ancient wanderers, and we are only just beginning to notice them. This leads us to the most unsettling speculative scenario of all, the dark forest hypothesis. This theory suggests that the universe is a dangerous place, and that any advanced civilization would be wise to remain silent and hidden to avoid attracting the attention of hostile species. In this scenario, interstellar objects like 3I/Atlas could be a form of cosmic census-taking. They fly by, gather data, and assess whether civilization is a threat. They could be a precursor to something far more deliberate. The fact that they have passed by without incident so far could be a sign that we have not yet triggered a response. But what if the data from Oumuamua and 2I/Borisov and now 3I/Atlas is being analyzed by a civilization that sees our rapid technological growth as a threat? The silence of space could be a sign of caution, a quiet that is chaos on a cosmic scale. But what if the real threat isn't a fiery impact or a gravitational upheaval? What if it's something far more insidious, something we can't see, measure, or even fully comprehend? This interstellar visitor, blazing toward us at a blistering 130 miles per second, isn't a danger to our cities or skies. It's a dagger aimed at the heart of our reality, a cosmic riddle that could unravel everything we think we know about the universe and our place in it. 3I/Atlas, with its eerie CO2, heavy chemistry, and ancient origins, might be an interstellar time capsule, carrying secrets from a galaxy we've barely glimpsed. Its very existence challenges our assumptions, forcing us to confront truths that could shake the foundations of science, philosophy, and even our identity as a species. The question isn't whether it'll hit us, It won't, passing safely at $1.80 in December. The question is, are we ready for what it might reveal? Buckle up, because this chapter dives into a mind-bending conspiracy theory. 3I/Atlas as a cosmic archive, not of alien tech or human deception, but of a long-lost galactic civilization's final message, designed to awaken humanity to a truth so profound it could either unite us or fracture us forever. If this hooks you, grab a telescope, join citizen science projects, or share your thoughts on X with hashtag 3iAtlasMystery. Your curiosity could spark the next great discovery. Let's rewind to July 1st, 2025, when Chile's Atlas telescope caught a faint flicker in the Lynx constellation, a speck racing on a hyperbolic trajectory, unbound by our sun's gravity, screaming Interstellar. Officially named C/2025N1, or 3I/Atlas, it's our third confirmed visitor from beyond, following Oumuamua's cryptic 2017 tumble and Borisov's glowing 2019 flyby. Its path, slicing through our system at 61 kilometers per second excess velocity, will see it graze the sun at $1.40 on October 29 to 30th, then swing past Earth at a safe 270 million kilometers in mid-December. NASA, ESA, and global observatories are clear. This is a natural comet. Its glowing coma, stretching 348,000 kilometers, driven by sublimating ices, its chemistry dominated by an unprecedented 8:1 CO2 to water ratio, hinting at alien formation conditions billions of years ago in the Milky Way's thick disk. Hubble's images show classic cometary behavior. Webb spectra reveal exotic volatiles, and radio telescopes hear only silence, no artificial signals. But here's the electrifying twist. What if this comet isn't just a rock but a deliberate archive, a message in a bottle from civilization that vanished eons ago, encoded in its chemistry, structure, and trajectory to deliver a revelation that could redefine humanity's destiny? This isn't about physical destruction. It's about a truth so shattering it could alter our worldview, spark global unity, or plunge us into existential chaos. Picture a galactic civilization. Let's call them the archivists, who thrived billions of years ago when our galaxy was a chaotic crucible of forming stars. Advanced beyond our wildest dreams, they mastered interstellar engineering, crafting objects that could survive eons of cosmic travel. Facing their own great filter, perhaps a cataclysmic war, a collapse into a black hole, or a transcendence into a higher state, they chose to preserve their legacy by seeding the galaxy with archives disguised as comets. 3I/Atlas, in this theory, is one such archive. Its CO2, heavy coma not a natural quirk but a deliberate signal. Its nucleus a crystalline vault of knowledge, data encoded in molecular lattices or quantum states, waiting for a species advanced enough to decode it. Perhaps they foresaw their end and sought to guide younger species past their own failures, embedding warnings about resource depletion, AI overreach, or cosmic threats like gamma-ray bursts. Or maybe it's a test. A civilization decoding the archive proves worthy of joining a galactic legacy, unlocking knowledge, advanced physics, interstellar travel, or even consciousness transfer that could catapult us forward. Darker still, the archive could be a trap, a mimetic virus that destabilizes societies by revealing truths too vast for our minds, like the insignificance of humanity in a universe of trillion-year-old intelligences. The CO2 anomaly, detected by Webb at $3 where most comets sleep, could be a beacon, its high ratio a deliberate marker to stand out against natural comets. The coma's vast extent, a controlled release of encoded particles, designed to interact with solar radiation in patterns we haven't yet recognized. To explore this, join SETI citizen science projects like SETI at Home. Your computer could process signals that reveal the archive's code. Let's weave the evidence, or its absence, into this gripping narrative. NASA's data is rock solid. 3I/Atlas follows a hyperbolic orbit, calculated with JPL's Horizon system, factoring in planetary gravity, relativistic effects, and solar radiation pressure. Its brightness peaks at magnitude 11, requiring powerful scopes, and vanishes in solar glare at perihelion, when activity like jets or outbursts should peak. Radio silence aligns with cometary norms. No narrowband emissions, just thermal noise from sublimating ices. The CO2 dominance fits models of formation near a star-snow line or radiation process crusts, with insulating dust mantles explaining early activity. But here's the hook that reels you in. What if this perfection is a clue? An archive would mimic a comet flawlessly, its signals subtle, perhaps quantum fluctuations in emissions or geometric patterns in the comet's dust, invisible to current tech. The thick disk origin, suggesting a 5 to 10 billion year age, supports the idea of an ancient sender. But what if the trajectory's odd angle is a coded path, pointing to a specific star or galactic coordinate? Dig into this by analyzing raw telescope data on platforms like Zooniverse. Your pattern recognition could spot the first anomaly. Now, let's amplify the tech angle to fever pitch. Crafting an archive to survive billions of years demands engineering we can barely imagine. The nucleus, estimated at 0.3 to 0.5 kilometers by Hubble's latest refinements, could be a lattice of diamond-like carbon or exotic metamaterials, housing data in atomic arrangements or quantum states stable across cosmic timescales. The CO2 coma, a dynamic shield, releasing particles that encode information in their spectral lines, readable by advanced spectrographs or future AI. Its power source might be a microfusion reactor, harvesting interstellar hydrogen, or a zero-point energy device, emitting CO2 as a byproduct to blend with cometary norms. The hyperbolic velocity, 61 kilometers per second, dwarfing Oumuamua's 26 kilometers per second and Borisov's 32 kilometers per second, could reflect a propulsion system, perhaps a gravitational slingshot engine programmed to visit systems with habitable planets. How'd it reach us undetected?